So let us solve this. Okay, to find the Fourier series for the function which is f of x is x plus x squared over the interval minus pi to pi. Okay. Now also we have to get the results for pi squared by 12, pi squared by 6, and pi squared by 8, which pi squared by 12, which is the summation of n is equal to 1 to infinity minus 1 to the power of n plus 1 by n squared, and pi squared by 6 we have summation n is equal to 1 to infinity 1 by 2n minus, this is n squared. Okay, this is n squared, and this is summation n is equal to 1 to infinity 1 by 2n minus 1 whole square. Okay, and also if you look at this problem also, so we need to find Fourier series for the function which is f of x is x into 2 pi minus x, which is over the interval 0 to 2 pi, and obtain the same result which we have done, which we have looked into the previous problem. Okay, so let us solve the first one. Okay, and obtain the results here. Okay, now the function here is x plus x squared. Now the function f of x is x plus x squared. This is neither odd or even. Okay, which is over the interval minus pi to pi. Okay, on the real line. Okay, now the f of x will be that is a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx, right? Now let us find the Fourier coefficients, which is a naught, an, and bn. Okay, yeah, now this is a naught is 1 by pi integral minus pi to pi f of x dx. Now this f of x is x plus x squared. Okay, so that will be 1 by pi integral minus pi to pi x plus x squared dx. Okay, now this is integrating it with respect to x. So this is 1 by pi x squared by 2 plus x cubed by 3. This is over the interval minus pi to pi, and this is over the interval minus pi to pi. Okay, now when you substitute when x is minus pi, okay, so which results to pi square by 2, and for pi it is pi square by 2, and for x cubed by 3 for the function is pi cubed by 3, and this minus of minus plus, which is pi cubed by 3. Okay, now this would lead to 2 by 3 pi square. So we got a naught, which is 2 by 3 pi square. Okay, got this result. Now let us find what is an. An is 1 by pi integral minus pi to pi f of x is x plus x squared cos nx dx. Uh, let us open the brackets, okay, and this will be minus pi to pi x cos nx dx plus integral minus pi to pi. This will be x squared cos nx dx. Close the curly braces. Now this is integrating by parts, that is 1 by pi. This will be x sine x nx by n, minus of cos nx by n square. Okay, this is again over the interval minus pi to pi here, plus now this will be for the second integral, so second term which we have, which is x squared. This is sine nx by n minus 2x minus cos nx by n square, right? Plus this is 2 minus sine nx by n cube. Okay, over the interval minus pi to pi. Close the braces. Yeah. Then now applying the limits here. This is 1 by pi, yeah, integral x by n sine nx minus pi to pi, right, plus 1 by n squared cos nx minus pi to pi, okay, plus x squared by n sine nx minus pi to pi, plus 2x by n squared cos nx, right, minus pi to pi, minus 2 by n cube sine nx minus pi to pi. Okay. Close the braces. Now, when you apply the limits for the following terms, so we get only one which is available, and which is two pi by n, yeah, cos n pi plus 2 pi by n squared cos n pi, right? Okay, and the rest of the terms is to 0. Now this would be 1 by pi 4 pi by n squared cos n pi. Okay, now this would be 4 by n squared cos n pi, which is equal to 4 by n squared. Cos n pi can be written as minus 1 to the power of n. So your an is 4 by n squared minus 1 to the power of n. Okay. Now let us find what is bn. again 1 by pi integral minus pi to pi f of x is x plus x squared sine nx dx. Okay, so this would be 1 by pi integral minus pi to pi x sine nx dx plus integral minus pi to pi x squared sine nx dx. Okay. Now again integrating by parts, this would be 1 by pi. This is x minus cos nx by n minus 1 into minus sine nx by n squared minus pi to pi, okay, plus x squared as cos nx by n minus 2x minus sine nx by n squared plus 2, this will be cos nx by n cube minus pi to pi. Okay. Now let us apply the limits. So 1 by pi integral minus 1 by n pi cos n pi minus pi by n cos n pi, and this is 0, and this is pi square by n cos n pi plus pi square by n cos n pi. Okay, and plus 0, and this is 2 by n cube cos n pi minus 2 by n cube cos n pi. Okay, so you can see the like terms get cancelled. So after simplifying it, we get minus 2 pi by n pi cos n pi, okay, which is equal to minus 2 by n cos n pi. So which is equal to this is 2 by n cos n pi is minus 1 to the power of n and minus 1, right, which is equal to 2 by n minus 1 to the power of n plus 1. So we got what is bn. Okay, 2 by n minus 1 to the power of n plus 1. Yeah. Now we got a naught, an, and bn. Okay. Now we got a naught, an, and bn. Let us apply in this. Yeah. And this. Okay. So that we can get the final result. So it is x squared plus x summation pi square by 3 after simplifying for summation n is equal to 1 to infinity minus 1 to the power of n by n square cos nx plus 2 times summation n is equal to 1 to infinity minus 1 to the power of n plus 1 by n sine nx. Okay. Now to get the results, let us apply x is equal to 0. Okay, so on the left hand side this will be 0. This is pi square by 3 plus 4. Sine 0 is 0 and cos 0 is 1. So this will be n is equal to 1 to infinity minus 1 to the power of n by n square. So now further, this will be pi squared by 12, okay, which is equal to minus summation is equal to 1 to infinity minus 1 to the power of n by n squared, or we can write this as summation n is equal to 1 to infinity minus 1 to the power of n plus 1 by n squared. Okay, so we got the first result, which is pi squared by 12, 1 by 1 square minus 1 by 2 square plus 1 by 3 square. Okay, and okay, let us consider this as 1. Now let us substitute x is equal to pi plus pi. Okay, so x is pi. Now this is pi plus this is pi square. Okay, and then when you simplify it, we get as 2 by 3 pi square 4 summation n is equal to 1 to infinity minus 1 to the power of n by n squared to minus 1 to the power of n. Okay, so which would lead to after simplifying this, this would be 4 summation n is equal to 1 to infinity 1 by n squared. Okay, let us keep this result as 2. Now let us substitute x as minus pi. This is minus pi plus 2 by 3 pi square and 4 summation n is equal to 1 to infinity minus 1 to the power of n by n square. This is cos of pi, which is minus 1 to the power of n. Again, this results to 4 multiplied n is equal to 1 to infinity 1 by n square. So let us keep this result as 3. Now when you add 2 and 3, right, so we get 4 by 3 on the left hand pi square on the left hand square, and this on the right hand side we will get 4 plus 4, which is 8 summation n is equal to 1 to infinity 1 by n square. Okay, or we can write this pi square by 6 summation n is equal to 1 to infinity 1 by n square, which is equal to 1 by 1 square 1 by 2 square and 1 by 3 square. Okay, so we got this result. Now let us take the result of 4 and the result of 1. Okay, adding these two, adding 1 and 4, which results to pi square by 12 plus pi square by 6 is 2 by 1 square and 2 by 3 square, 2 by 5 square, and so on. Yeah, again after simplifying this you get pi square by 8 by 1 square, 1 by 3 square, and 1 by 5 square, and so on, which is equal to summation n is equal to 1 to infinity 1 by 2n minus 1 whole square. Okay, so hence we got following results. Okay, which is pi square by 12 and pi square by 6 and pi square by 8. Okay, Now let us expand the function, which is f of x is x multiplied 2 pi minus x. Okay. Now this is over the interval 0 to 2 pi. Okay. This is the function now. And again, getting the same result which we have seen in the previous problem. Okay. These results. And the function is this, was this here. And this was over the interval minus pi to pi. Okay. Let us solve this. Okay. Now your f of x is x multiplied 2 pi minus x, which is 2 pi x minus x squared, right? Okay. You got to find a naught, an, and bn. So let us find it. Okay. Now a naught is 1 by pi integral 0 to 2 pi. This is 2 pi x minus x squared dx, or 1 by pi 2 pi x squared by 2 minus x cubed by 3. Yeah. Now over the interval 0 to 2 pi. Okay. 0 to 2 pi. Yeah. Now let us substitute it. This would be is pi multiplied into 4 pi squared minus 8 pi cube by 3, right? So what we get as 1 by pi 4 pi cube by 3, which is equal to 4 by 3 pi square. So what we got as the Fourier coefficient, which is a naught 4 by 3 pi square. Okay. Now let us find what is an here. By pi integral 0 to 2 pi f of x is 2 pi x minus x squared cos nx dx. Okay. Now let us integrate it with respect to x. So this is 2 pi x minus x squared. Integration of this would be sine nx by n minus 2 pi minus 2x minus cos nx by n squared. Okay. And plus minus 2 minus sine nx by n cube 0 to 2 pi. Yeah. Over the interval for that, I think. Now let us apply the limits. Now this is 1 by pi two pi x minus x squared sine nx by n 0 to 2 pi plus 2 by n squared pi minus x cos nx 0 to 2 pi plus 2 by n cube sine nx 0 to 2 pi. Yeah. So this will be 1 by pi 0 plus 2 by n square. This is pi minus 2 pi, right? cos 2n pi plus and this 0 minus pi cos 0, right? So this would write 1 by pi multiplied 2 by n square. This is minus 2 pi, right? So this is minus 4 by pi, 4 pi by pi n square, which is minus 4 by n square. So we got an as minus 4 by n square. Okay. Now, for this, now let us find what is bn. 1 by pi integral 0 to 2 pi 2 pi x minus x square sine nx dx. Okay. Now this is 1 by pi 2 pi x minus x square and minus cos nx by n minus 2 pi minus 2x integrating by parts. So minus sine nx by n square plus minus of 2 and cos nx by n cube. Now with respect to 0 to 2 pi. Okay, close the brackets. Now let us individually find it. Pi x minus x squared minus cos nx by n 0 to 2 pi plus 1 by n squared 2 pi minus 2x sin nx 0 to 2 pi minus 2 by n cube cos nx 0 to 2 pi. Okay, be 1 by pi after substituting this, right? And minus 1 by n and again this also will be 0. So we got as bn as 0. Okay, now let us apply for the function. Now let us substitute a naught, an and bn here, right? So since we don't have bn, so your function f of x, which is x 2 pi minus x, is 2 by 3 pi square minus 4 summation n is equal to 1 to infinity 1 by n square cos nx. Now for x is equal to 0, this is 0, 2 pi square by 3 minus 4 summation n is equal to 1 to infinity 1 by n square, or we can write this as pi square by 6 summation n is equal to 1 to infinity 1 by n square after simplifying it. Okay, we got this result. Now this will be 1. Okay, now 1 x is pi. Okay, this will be pi square, which is 2 by 3 pi square minus 4 summation n is equal to 1 to infinity by n square cos n pi, or this pi square by 3 minus 4 summation n is equal to 1 to infinity minus 1 to the power of n by n square, or we can write this as pi square by 12 summation n is equal to 1 to infinity minus 1 to the power of n plus 1 by n square. Okay, let us keep this as equation 2. Now adding 1 and 2, this is pi square by 6 and pi square by 12. We have the left hand side. On the right hand side, we have summation n is equal to 1 to infinity 1 by n square plus minus 1 to the power of n plus 1 by n square. We open the brackets and try to simplify it. This is 2 by 1 square, 2 by 3 square, and 2 by 5 square, and so on. Or we can write as summation n is equal to 1 to infinity 2 by 2 minus 1 whole square. Okay. And further simplifying it. So now that we got this, now on the left hand side, it is pi square by 8, multiplying into 2, and summation n is equal to 1 to infinity 1 by 2n minus 1 whole square. So we got this also. So we got pi square by 6, pi square by 12, and pi square by 8 for the function which is x multiplied 2 pi minus x. Okay.